All right. So what about something like this now? We're trying to solve a linear system here, right? So, or a linear quadratic system. This equation right here, its graph would be a line. Riley, what's this one going to be? I'm going to have x squareds, right? And I'm going to have y's not being squared. What's that seem like that's going to be? Okay, quadratic, so what's the shape going to be then? Okay, parabola, so that's going to be a parabola, that's going to be a line. We're looking for the intersections, if you think of it in terms of a graph. Yes, sir? What's that? Oh, it is slip function. You're right. Thank you. All right. So we're looking for the intersections in terms of a graph, but we're not going to do this one graphically here, right? That's the last assignment you get to use Desmos, and that's quick. That one takes 5 minutes. Just plug them in and find the intersections. But here we're doing it algebraically, right? So algebraically, what does that mean? Well, we want to find the values of x and y, which would correspond to points on the graph that are going to make each of those equations true, right? So how do we solve the system then? We're going to substitute, right? We're going to substitute from one equation into the other. Well, this one's pretty simple. What variable are we going to substitute? Y. Yeah, we've already got this one solved for y, don't we? So there's our substitution equation. And we're just going to sub in for y right there, right? So that top equation then becomes what? So the left side doesn't change. We've got x minus 3 squared equals negative y. But y we're going to trade for 2x minus 12. Minus 6, right? So there's our equation. That looks ugly, right? But just think about how what's going to happen here. It's an equation. How many different kinds of variables do we have in this equation? One, just x's, right? So we can make this easier. Would you agree that when all the dust settles, after we simplify all this stuff, I'm going to get some x squareds. When I square that out, would everybody agree I'm going to get some x squareds? Right, so I'm going to get x squareds. I already have at least one x. I'll probably get an x term there. So I'm going to get some x's, and I'm going to have some numbers, right? So that's a quadratic equation. Now, what am I going to want to do with that? How do I solve quadratic equations? What form do I need to put them in to start?
Or the standard.
Standard form, right? I got to put them into the form. I got to get it into the form ax squared plus bx plus c equals 0, right? Got to get it equal to 0. So that's my goal. If I can do that with this, then it's not going to be hard. Then it's just a quadratic equation. In worst case scenario, I can just plug it in the quadratic formula. It's easy, right? Maybe there's something quicker to do than that even. But we got to get to there first. So that's the goal then. How do we do that? Say it again?
Move the right equation to one side.
Okay, we're going to move everything to one side eventually, but even then, that doesn't look anything like that, right? Like in here, I've got an x minus 3 in a quantity that's being squared. I've got a negative 1 that's being multiplied by a quantity. I've got lots of stuff to deal with, right? What are the things I have to do to make this simpler so I can eventually just put it into standard form?
Distribute.
Okay, I got to distribute, and I'm going to simplify in general, right? So when we simplify, there's a way to organize the way we simplify stuff, and it's just order of operations, right? So that's what I really kind of big picture I want you to see here is that first thing we got to do is get it into that form, and to get it there, all we have to do is simplify, right? And that's a process where we go regular, top to bottom, order of operations. Whenever I go through order of operations like this, and I do all that stuff, I end up with this as a result, right? It's automatically going to put it into standard form. That's the whole point of simplifying, is that it puts an equation into the simplest form, which is standard form, okay? So let's just tick off those layers and see what we get. So inside the parentheses, is there anything I can do? X minus 3, nothing, they don't combine. 2x minus 12, they don't combine. So I can just eliminate that step, nothing to do. Exponents.
Yeah.
Yeah, there is an exponent, right? We've got an exponent right there. Okay, so what's the pattern I'm going to follow with this one?
Distribute.
Well, I mean, so you could say x minus 3 times x minus 3 and distribute. Yeah, you could. That's fine. But let's use our pattern. What's our pattern? This looks like something minus something squared. So that's the a minus b squared pattern, right? Everybody agree? So what does that pattern equal to? That equals
A squared minus B times
2AB
2ab, good,
plus B squared.
plus b squared. That's the pattern we're going to use, right? So our a is an x and our b is a 3, right? And so all this stuff right here just becomes what then? A squared would be
X squared.
x squared minus 2 times x times 3. What's that? 6x plus 3 squared is 9, right? So that's everything on the right side. When we use that pattern, we expand that out. And then on the left side, we're just stuck with what we had. Okay, so we did the exponent step. What's next? What do I multiply here? Okay, I've got a negative 1 being multiplied by this quantity, so I've got to distribute the negative 1. All right, so if I distribute the negative 1, that's just going to change those signs, right? So I get negative 2x plus 12 minus 6. And then last step, add, subtract. Anything to add or subtract?
Yes.
What?
The 12 and negative 6.
12 minus 6. Okay, so that's just going to become a 6, right? So x squared minus 6x plus 9 equals negative 2x plus 6. All right, so now it's easy. Last thing I got to do to put this into standard form.
Move it over.
Move it over. Which side am I going to move it to?
Left.
Left side, because that's a positive number of x squareds there, right? So we'll add 2x to both sides. So I'm going to get a negative 4x. If I subtract 6 from 9, I get
3.
okay, and so that's my quadratic equation. Well, that's a lot better than that, isn't it? Right? After we simplify, it turns into something pretty easy. And so how would I go about solving that? Now think about this. Don't say, nobody say it yet. This is where we're in chapter 5. This is kind of the next assignment that you're going to have is, I don't care about even what the answer is. I just want to know what's the best way to find the answer. Which of our methods are we going to use to solve? Can we isolate x directly? No, because I've got an x squared and an x, right? Can I find magic numbers? Chris, can I find magic numbers?
No.
Yeah, maybe you can.
Yes.
You're not going to find it with your eyes closed, though. That's for sure. What do you think?
That's better.
Numbers that multiply to 3 and add to negative 4. What would the signs have to be? If you're going to multiply to a positive and add to a negative. They have to be negative. So if it works, I'd have that, right? And what would they be? Numbers that multiply to 3, add to 4.
Negative 3, negative 1.
Okay. Right? Negative 3, negative 1. And so this one, I mean, we could have used quadratic formula. It would have been fine. We could have completed the square, but this is so much quicker. If you can find those magic numbers, it takes 2 seconds, right? So what are the solutions then?
3 and 1.
Either x equals 3 or x equals 1, right? But that's not, we're not done yet, right? That's just the x part. We need to find the y coordinate also. Well, where do we go to find the y coordinate?
Other,
Equation.
The boxed equation, yeah, right? The one that, our substitution equation, it's already solved for y. So Riley, what am I going to get if I plug in x equals 3? What am I going to get? So y equals 2 times 3 minus 12. What's that going to be? Negative 2 times 3 is what? 6 minus 12? Negative 6. Okay, there we go. So the first one is gonna give us the ordered pair 3, -6, right? Second one, what's that gonna give us? Sean, if I plug a 1 in there, what am I gonna get?
-10.
-10, right? So the second one's gonna give us the ordered pair 1, -10. So those are our two solutions, right? How could we check it? Plug them back in, yeah. Both of those should work in both equations. Okay, let's try another one. There's something different's gonna happen here. This is a little tougher one. This is a pretty, I mean, it's pretty hard. I mean, I don't want you to think it's something you can't do, though. It is, but you just have to persevere with stuff like this. It may seem, and I remember this feeling really well. I've been in those desks before, and I've been in those desks in college and graduate school, and it never changes. There's always, you do stuff and you feel like, oh man, that's never gonna work. But if you just don't get intimidated, don't get psyched out, and you just take it step by step, and you're careful, it works. Math just works. And if you follow the rules, it has to work. So what are we gonna do with this one? What's our strategy gonna be here to solve this? It's a system. What could we do? Doesn't even.
So instead of taking the x's, do a y, change it to the y, so make the logic equation x equals whatever.
So what variable am I gonna substitute here? What am I gonna solve for and substitute? Yeah, we could, right? Okay, but now here's the issue with that. And I think maybe what you're thinking is that there's something, the reason maybe we wouldn't want to use y, and we could do either one. There's never like one that we can do and the other one we can't do. There's always an option. But if I substitute for y, maybe you're thinking, and this makes sense, the y is inside a quantity that's being squared, and so that could make things a little more difficult, right? If I'm going to substitute into something and then have to square it. That's true. Okay, but if I want to solve for x, look at the problem we have. If I isolate x in the bottom equation, does anybody see something about that that's kind of ugly? Yeah, I got divided by 4, right? So if I want to solve for x, I'm going to subtract the y over here. And then I have to divide by 4. Well, that 32 divided by 4 is fine. But y divided by 4, not so good. I'm going to end up with a fraction when I substitute. We don't want to be substituting a fraction, do we? If I substitute a fraction up here, then I'm going to have to deal with those fractions, right? Unless we can do this in a way where we don't have to substitute a fraction, right? So how could we, does anybody have a different plan? And one other plan would be just don't solve for x. What could we solve for instead? Y. Sure, and the bottom one would be easy to isolate y, wouldn't it? What do we get if we isolate y?
4x plus 30, or negative 4x.
Negative 4x plus 32. Okay, so there's one thing we could do, and then just substitute for that y. That's fine, we could do that. That's probably the way we'll end up doing it, but is there a way we could have made this work? Instead of substituting for x in the top equation, anybody see a trick here? What can we do? Multiply by 4, very good, right? We could do this. We could multiply through the top one by 4. What if I multiply each side of, it's an equation, so I got to treat both sides equally, right? Here, I'm just going to write this out. So if we multiply both sides by 4, that's all I did, right? I multiplied the left side by 4 and the right side by 4. What am I going to get on the left side if I distribute that 4?
4x plus 1.
Okay. On the right side, how many things are being multiplied? Really there's not so many. 3 things, right? I've got 4 times negative 3 times the quantity x minus 6 squared. Now when I multiply stuff, I don't distribute, right? When I multiply factors like that, I just multiply things in pairs, right? If I were to multiply out, this is an example I always use, 2 times 3 times 4, what's the answer? I heard it. 24. How'd you get 24? So 2 times 3 is 6, times 4 is 24. Good. Or I could have done 2 times 4 is 8 times 3 is 24. Or I could have done 3 times 4 is 12 times 2 is 24. But what I don't do is multiply the 2 times the 3 and the 4. That would give me 48, which is incorrect, right? My point being then, when I multiply these out up here, 4 times negative 3 just becomes negative 12, which is what we're going to end up multiplying by y minus 6 squared. You see, that was a really good idea, right? Now, why is that such a good idea? This equation goes well with this one. How come? Lauren, what were you seeing there? You had a really good idea. What was your plan then?
Then the y would be 4 over 1 and just be y.
Okay, so we could just get the 4x by itself, couldn't we? We could just say, oops, we could just say 4x equals negative y plus 32. And that becomes our substitution equation because we could just substitute for the 4x, right? That's pretty good, right? So then we'd end up, when we do that, we'd end up with, instead of a 4x, we're going to get a negative y plus 32. Plus 12 equals negative 12 times y minus 6 squared, right? And that's not bad. That's actually a pretty good way to do it because look, what we're squaring out is relatively small then, right? Okay, but let's say we didn't see that. That was pretty tricky. Good idea. We could always just make this substitution, right? So now we end up with the top equation. We get x plus 3 equals negative 3 times y. Well, what's y? Negative 4x plus 32 is my y, minus 6 squared, right? How many different kinds of variables are there? I mean, that y is not there, right? Only one. So we can do this, right? We can simplify this to put it into standard form and then just solve the quadratic equation. Okay, so let's go through our steps. What's the first thing we have to do to simplify? In the parentheses, right? If we do order of operations, first we're in parentheses. Well, in the parentheses, we can do something here, can't we? Negative 4x plus 32 minus 6 is what? I can combine the 32 and the negative 6. What's that?
26.
26, okay. On the other side, still got our x plus 3. Okay, what's next? Exponents. So we got to multiply that whole thing out using our pattern, right? So, I mean, these are big numbers, I'll grant you. But if I'm going to square this out, let's just expand this out using our pattern. So this is like A, and that's like B. So first thing we do is A squared. Well, what's negative 4x squared?
16x.
Yeah, right. Negative 4 squared is 16. X squared is x squared, right? What is 2 times... Okay, yeah, you know, let's do this. How about, because so we can make this look more like our pattern, let's just make one little tweak here. I think you'll like this a little better. So if we make this 26 minus 4x quantity squared, right? So now it looks like A minus B, right? So 26 squared is 25 squared plus 51, so that's 676. What's going to be 2 times 26 times 4x? Okay, 2 times 26 is what? 52, good. And if I multiply something by 4, I'm just going to double it and double the result. So what's 52 doubled? 104, what's 104 doubled?
208.
208. So 208x, and then finally we get our b squared, which is 16x squared, right? Okay, so we're going to get that. Okay, what's next?
Divide the negative
No,
No,
hang
you
on.
distribute.
Distribute, right, because we're simplifying, we're not solving. So we're gonna multiply by -3, right? So if I distribute, all right, you guys get your calculators out. It's gonna be, oh my gosh,
It's gonna be a number.
2048.
yeah, 2020.
2048.
Okay, and then we're gonna get plus. Those are big numbers, but you can use calculators. I mean, it's not a big deal, right? They're just numbers. All right, so don't panic when you see big numbers. Now what?
Switch the sides.
What's that?
And move it to the right side.
To the right side?
Well, to the left side.
To the left
The
side,
right
good.
side is what-
Okay, good, because we want the positive number of x squareds, right? So we're gonna push everything over there. So we're gonna add 48x squared to both sides. We're going to subtract 624x from x. So that's, what's negative 624x plus x?
Negative 623.
Good. And then we're going to add 2028 to 3, right? Which gives us plus 2031. Huge numbers, right? Huge numbers. That looks terrible. But,
But then you could divide by 48.
well, 48 unfortunately isn't going to go into these things, right? So we're stuck. But what do we do if are we going to try to factor that? No way. I mean, if it factored, it'd not be worth the hassle at all, right? It'd be a huge bottoms-up problem, take you forever, not worth doing. We gonna try to complete the square with that? No way. What are we gonna do? Quadratic formula, yeah. What we're gonna do with this is just put it into quadratic formula and let our calculators do all the work for us, right? So what would we get? There's the quadratic formula on the board. Here's A, there's B, and there's C, right? So we're gonna get x equals negative b plus or minus the square root of b squared. So negative 623 squared. That's the same thing as positive 623 squared. So I'm just gonna write that because it's easier, right? Minus 4 times 48 times 2031. That's gonna be a pretty big number, isn't it? Right? So what might happen here? Inside the square root. The discriminant might be negative, right? 623 squared minus 4 times 48 times 2031. That's going to be a bigger number than that, right? I mean, we'll verify it for sure, but I'm pretty confident it is. Divided by 2 times a. So think what the directions were on this problem. Let's go back to the last one. The directions were find all real solutions, right? If they're not real solutions, what are we going to do? We're just going to enter false instead of having to do all that work. So what do we want to do first when we're solving this problem? When we're using the quadratic formula, whoops, here, there, what part are we going to evaluate first? Because we don't want to do more work than we have to.
Inside the,
Yeah, we're going to look at the discriminant, the part that's under the radical. And if that's negative, what do? False, right? Because there's no real solutions. So let's just take that part. Let's pull up our calculators. And okay, so what are we going to get? If we just do, let's just evaluate that part inside the parentheses first, or inside the square root first. And if it ends up being positive, then we'll just plug it into the formula. So 623 squared minus 4 times 48 times 2031 is negative. We're off the hook, right? So the answer is false. Yeah, is that it right there? Well, that's something different. Anyway, the answer would be false, right? Okay? All right, so last one. I'm gonna let you guys work. So what about something like that? Does that look different?
And
Something about that looks different.
there's two
parentheses.
Yeah, both the x's and the y's are being squared in the top one. What's that gonna look like? Do you think?
Not in the decimal.
Okay, so there's everybody agree, there's the top equation right there. X plus 6 squared plus y minus 2 squared equals 50, right? Okay, so if I graph that, what it is, a circle, okay? And then the other one, x minus 7y equals negative 20 is a line. And so the intersections on Desmos, I can find them easily. There they are, right? So that's the second assignment, right? Negative 13, 1 is one ordered pair. That's a solution, and the other one is 1, 3. Okay, real quick, because this is actually a pretty quick one. Well, how can we solve that algebraically? What are we going to do? What are we going to substitute here? X. Yeah, x is easy to isolate in the bottom equation, right? So I can get the x by itself. X is just equal to 7y minus 20, right? Okay, so then I'm going to plug that into the top one right there. And that gives me what? X plus 6 squared plus y.
I.e.
Oh, other way around. Whoops, is that other way around? Okay, so in the top equation, instead of an x, we're going to plug in 7y minus 20 plus 6 squared plus y minus 2 squared equals 50. Okay, so now we'll just simplify, right? What's the first step in simplifying here? Parentheses. Can't do anything there, but I can there, right? What do I do there? Add 6, okay. So 7y, what, minus 14 squared equals y plus, oh sorry, plus y plus 2 squared equals 50. Now what? Exponents. Okay, so I've got a minus b squared is a squared. So what's the quantity 7y squared?
49.
Good. 49 times y squared. Good. Minus 2 times a times b. Well, 2 times 7 is 14. Times 14. What's 14 squared? 196. Good. So we get minus 196y plus b squared. Well, that's 14 squared. 196, right? Plus, how about here? A squared
Y squared.
plus, this is a plus, right? Plus 2 times y times 2 plus 2 squared, right? Now what? Combine like terms. So y squared plus 49 squared, 50y squared, good. Sean, what's negative 196y? Let's see, did I write this down wrong?
I can't see it right. That's
Also, you said your 2 is.
Oh, that's supposed to be a minus 2, isn't it?
Yeah,
Yeah,
now
no
we
wonder.
use.
Yeah, I gotta change that. Come on. Okay, so that was supposed to be a minus 2, and now that's going to give me a minus b, right? So I'm going to end up with a squared minus 2 times y times 2 plus 4, right? Okay, so Sean, back to you then. So we got to combine these things. Negative 196y and negative 4y is negative 200y. Good. And then 196 plus 4, 200 minus 50. 200 on this side, I'm going to subtract the 50 from both sides. 150. Okay, we could make that a lot easier. Can I divide both sides by something? 50, yeah, right. If I divide each side through by 50, I'll just divide each term by 50. And what do I get? So I got 0 on this side. These 50s cancel. So y squared minus 200 over 50 is what? 150 over 50. That's the same thing we had last time, isn't it? Same quadratic equation. What were the solutions to this?
-3 or 4.
Yeah, right, we factored it into y minus 3. It was x last time, but y minus 3 and y minus 1, right? We have magic numbers. Multiply to positive 3, add to negative 4. So what are the solutions then? Either y equals
3.
or y equals 1. Where do we go to find the other half of that, the x values?
Plug it into the equation, the line.
Yeah, the boxed equation, right, the substitution equation. So what if, Kyron, if y equals 3, what are we going to get then? If I plug 3 in for y, what's x going to be? 7 times 3 minus 20. 1, good. 21 minus 20 is 1. So we end up with, this gives us the ordered pair x is 1, y is 3. How about this one? We know y is 1. What's the x going to be? If I plug in 1 for y, what do I get? 7 minus 20, negative 13 for x. So 1, 3, okay, 1, 3, and negative 13, 1. Well, that's what we had, wasn't it? On Desmos? Where'd Desmos go? Somewhere. Yeah, those were our spots. There's negative 13, 1, and 1, 3, right? Okay, we good? All right, I'm going to let you work. How much time we got?